we will now bring the concept of covariance and correlation. Okay, first let us see what is a covariance. Okay, note that covariance, it tries to measure how the two variables they move with respect to each other. So covariance, it measures how two variables they are moving with respect to each other, right? So the covariance is actually your expected value of the multiplication of the deviation of the two variables. So this is your deviation of the first variable, this is your deviation of the second variable. The expected value of that is your covariance. So this formula is a complicated formula. We can see a simple formula. The covariance is given as summation of pi into xi minus ex, okay, that multiplied with yi minus ey. This is your covariance formula, right? So pi into xi. So now what it means is that the deviation of x, when x is deviating with this probability, what is the deviation of y? Okay, or with this probability, what are the deviation of x and y? So this is the one way to get the covariance, right? Now you may wonder that how this covariance is coming. So for that, let's see this. First we will bring the concept of this. Okay, this was your value, this was your expected value, and this was the variance. Now how this pi is coming? Remember, in your descriptive statistics we said that the variance is given as this by n, or we can write this as 1 by n and xi minus x bar whole square and then summation. Now when you have n number of data and you want to pick up one, the probability of that selection is 1 by n. So it means that this 1 by n can be replaced with probability of selection of that item. Note that here it was all were equally likely to come, but in real life all are not equally likely to come. So that's why we can replace it with pi, and then we have xi, and we said that expected value is nothing but the x bar. So this is your variance. Okay, covariance, it is how two variables are moving with respect to each other. So rather than talking about the square, what we do is we multiply this with your yi minus your expected value of y. So this will become your covariance. Covariance in case of your descriptive statistics is this. It will be your xi minus x bar yi minus y bar divided by n. This is your covariance in the descriptive statistics. But in expected value, we say that because we are bringing the concept of expectation, so xi minus ex, yi minus ey. This is your covariance formula, right? Now let us try to understand the properties of the covariance. So what are the properties of covariance? Covariance, it ranges from minus infinity to plus infinity. So note that covariance can be minus infinity, covariance can be plus infinity. This is the range. Okay, now the covariance of a variable x with itself is your variance of x. So let us try to understand. Remember, we said that covariance is variance is given as xi minus x bar, or let's say x bar whole square summation divided by n, and we saw that covariance is written as xi minus x bar yi minus y bar divided by n. This is the covariance between x and y. If I want to know the covariance between x and x, what I will do is I will replace this y with x, so it will become xi minus x bar minus x bar divided by n. So xi minus x bar is multiplied 2 times, so this will become this. So it means that covariance of x and y is nothing but it is a variance of x. So this is one of the property. It ranges from minus infinity to plus infinity. Then second is variance. Covariance with itself is variance. If there is no relationship, we'll say that the covariance will be equal to 0. And the unit of covariance is same as your variance, that is, it is your squared unit. Okay. Now one of the drawback of using the covariance is that it is not able to measure the strength of relationship. Suppose let's say between x and y the covariance comes as 100, and between x and z the covariance comes as 200. Okay. Now here the covariance is higher. It does not mean that the relationship strength between x and z is higher than xy. Okay. We will see that we need to standardize this covariance to get the strength of relationship. So higher covariance does not mean that the relationship is better.